Hello and welcome everyone. Today I will be making a humble effort in trying to explain a domain that has filled up each and every part of our lives and will continue to do so even for generations to come. In this era of machines and automation, artificial intelligence plays a pivotal role in enabling seamless machine-related tasks to simplify and support humans in each and every walk of life. Now let us understand what really makes up this enthralling subject of artificial intelligence. A major portion of artificial intelligence is made up of machine learning, which in itself contains another recently advancing domain of deep learning. To tie all of this up, data science becomes critical to bridge the domain of algorithms that artificial intelligence is made up of to math and statistics, thus forming the fascinating domain of data science and machine learning, which we will delve deeper into in the next few sessions. The real life problems, especially talking about the business problems, can be analytically converted to a data science and machine learning problem based on the objective. To serve different objectives, the domain itself is divided into three broad categories, which are supervised learning, unsupervised learning, and semi-supervised learning. Under supervised learning, the two subcategories are regression and classification. Whereas in unsupervised learning, there are three subcategories. One is clustering, the other is NLP, that is natural language processing, and then we have image processing. Semi-supervised learning for now is beyond the scope of our discussion. To solve a regression problem, we have multiple algorithms and we will be looking at some of the most used machine learning techniques here, like generalized additive models, tree-based models, and support vector machines, that is SVM. Let us look at the subcategories of the generalized additive models. The first subcategory is linear regression, followed by the ridge regression, and then we have lasso regression. Likewise, tree-based models are subcategorized into three subcategories, which are decision tree regression, bagging, that is random forest regression, and boosting. Boosting is categorized into adder boost and gradient boosting. And gradient boosting is further subcategorized into extreme gradient boost, that is XGBoost, and light gradient boosting model, that is LightGBM. Some of the widely used machine learning algorithms to solve a classification problem are logistic regression, tree-based models, support vector machines, that is SVM, and naive-based classification. Again, tree-based models are subcategorized into decision tree classification, random forest classification or bagging, and boosting. Whereas boosting is further categorized into two subcategories that are adder boost and gradient boosting. And gradient boosting is further subcategorized into extreme gradient boost, that is XGBoost, and light gradient boosting model, that is LightGBM. To even enter this space of machine learning, certain basic concepts need to be well understood, which are measures of central tendency like mean, median, and mode, measures of spread or measures of dispersion like variance, standard deviation, etc., measure of symmetry, that is skewness, measure of tailness, that is kurtosis, and a few basic concepts of probability like general rules of probability and types of probability. Adding to this, the concepts around random variable with understanding on the difference between discrete and continuous random variables, extending this to probability distributions, bifurcated into discrete probability distributions and continuous probability distributions. The normal and the standard normal distributions under the continuous probability distributions will be dealt with in detail. Along with this, a few fundamental premises around probability and statistics like central limit theorem, p-value, and significance level will be covered. So in this session, we have just brushed the surface of machine learning and data science. We will continue to go deeper in each of the areas discussed today, covering the essential math as well as business intuition behind each of the algorithms. Thank you and see you in the next session.